Today's lesson is Science in Context. As we go through this lesson, the desired results or learning objectives, basically what you should be able to do is you should be able to describe how attitudes and experiences generate new ideas. You should also be able to explain why peer review is so important. We're also going to ask that you explain the relationship between science and society. How are they connected? And also, you will be able to list the practices that are common to both science and engineering. The nature of science is very dynamic, flexible, and unpredictable. It's just its nature. What might be some useful qualities of a scientist? What kind of qualities would a scientist need to have? You could probably pause the video and come up with a nice long list. But you'd probably come up with things like curiosity, maybe even skepticism. Obviously, creativity would probably fit in there pretty nicely for a scientist, and being open-minded would also be useful for a scientist to have that sort of a characteristic. So we could add a list like that. There's probably some other terms, some other adjectives that you came up with that might describe qualities and characteristics that would serve a scientist very well. Ideas in science can arise in a lot of different ways. They can come from simple curiosity all the way up to the need to solve some particular problem. So think about this. What present-day issue or problem poses a question that scientists could address? I'll give you a minute to think about that. I would recommend you pause the video here and think about how that might work, or what kind of problems scientists might be able to address that we face today. You might come up with things like how to reverse climate change, or how to clean up pollution problems, or maybe even how to tackle childhood obesity. Technology plays an enormous role in science. Technology provides new opportunities to ask questions and to gather new forms of data with greater accuracy and quantity. So technologies that are developed by scientists have often proved to be very helpful to society. So think about some things, some pieces of technology that have been invented recently that have been helpful to your lives. And think about why those things are helpful to your lives. Now, obviously, the first one probably everybody thought of is cell phones, but maybe there's some other things that are less obvious that you could come up with. Maybe something in the field of medicine, or something industrial, or maybe something automotive, or something in your household, some technology that impacts your life, that is very helpful to you. What about education? I think you should probably be able to come up with one there, given the school that you are enrolled in. How about the government? Is there any new technologies that the government utilizes that makes your life easier? Interesting thing to think about. When a scientific paper is published, does that mean that research about their topic is complete? Why or why not? Well, if you recall, in our last lesson, we talked about how science is never truly settled. We're always trying to disprove hypotheses and theories. Publication of a paper that covers some certain scientifically researched topic doesn't mean, just because it was published in a paper, doesn't mean that the research about that topic has been completed. In fact, it may open doors for a lot of new studies about the same or similar related topics. For instance, a scientist that discovered a certain species of plant could use a chemical signal to call in a species of wasp to attack insects eating its leaves. And from this discovery, a plethora of other questions can arise and then be investigated. So, what are some questions scientists could investigate based on this discovery? Well, they maybe could study things like, do all plants signal with other species? Or do all wasps respond to plant signals? Which plants utilize signaling to defend themselves? Other questions that could be answered by science are there other defensive signals that work in other ways? What benefit does the wasp receive in responding to the signal? Or even, how did this signaling relationship evolve in the first place? So, a major way that scientists communicate and keep information objective is through peer review. Very important, this peer review. Publishing articles in a peer-reviewed scientific journal allows researchers to share ideas and allows other scientists to evaluate and test the data and analysis. So any scientist that claims to have discovered something new has to be willing to reveal all of the details for peers to be able to scrutinize and test for themselves. And this leads to a robust bank of knowledge that is ultimately credible when they all agree. So think of some topics relating to social issues. And what role does science play in personal or public health and environmental issues? Some of those topics might be the effects of drug and alcohol, or high blood pressure, or even diabetes, AIDS, cancer, heart disease. All of those topics are related to social issues. So think about how science might influence society. Well, when we have scientific data, that helps provide answers to questions that affect our everyday lives. So science really is connected to our daily lives. Scientists don't work in a vacuum. I think that's kind of the main point here. Instead, their research is strongly influenced by society. So how does society influence science? Well, society can actually limit the application of scientific ideas, especially if the new scientific ideas conflict with prevailing cultural beliefs. For example, it used to be legal to smoke cigarettes in public places. Scientific studies proved that secondhand smoke was dangerous, and people started to see cigarettes differently. Eventually, the laws changed, banning cigarettes from most public indoor areas. All right, so although some of the specifics vary, the steps in scientific inquiry and in engineering design are basically the same. So, in science and engineering, there are questions that get asked and problems that get defined. Both science and engineering develop and use models, and they plan and carry out investigations. Of course, once they plan and carry out investigations, they're going to have to analyze and interpret the data that they collect during those investigations. Both science and engineering use mathematics and computational thinking, and both construct explanations and design solutions. Science and engineering both engage in argument from evidence, although More recently, we've seen the politicization. What is that word? Politicization of the sciences, which is not a good thing. It's a bad thing, where people are using certain data and conclusions that fit their own narrative to make their own point, to push their own agenda. So it's important that science and engineering both argue from a point of evidence and not just biased evidence that fits their narrative, but the truthful, understood to be truthful evidence. And both science and engineering work to obtain, evaluate, and communicate information.